All right. So I decided to just make a video of this already because I have my key here, but why not go over it? So I will scan this as well. If you just want the PDF, it's going to be up shortly. So here we have, consider two similar cones shown below. By the way, this page and the previous page on 34 are there to kind of just illustrate um, the fact that the scale factor, once determined, regardless of whether we use one-dimensional measurements or two-dimensional or three-dimensional, it doesn't matter. The scale factor, which is what has affected each single dimension from one to the other, right, stays the same regardless of how you approach it. So you're not really solving for anything, any missing part. It's a scale factor that we're just trying to see how they're always connected. So here we go. We have the word original here, which means this is the new one. We can observe that a reduction happened, right? So by what factor has the height and the radius been affected? So let's do the radius first. Okay, so we have k is radius of the new one divided by radius of the original, right? So we have radius of the new is 5 centimeters, get this right. And this is, sorry, not 5, we're talking radius, 2 centimeters. Phew, right? And 14 centimeters is the original. Cancel that out. So that's k is equal to 2 over 14, which if you reduce it on your calculator, it's really 1 over 7. And if you divide that, you get 0.1429. I rounded it to 4 decimals. So then it's just easier to get it straight to a percentage. So there has been 85% or so reduction, right, from one to the other. That's using the radius, and the height, we should get the same, right? So if we do height, height of the new one would be 5 centimeters. The height of the original, 35 centimeters. Cancel that out. Sorry, this should be k, not height. My bad. So that's 1 over 7 reduced because 5 goes into both, right? So that's 1 over 7, and there you see it's going to be the same, right? So we have 1 over 7 for the radius, same for the height. So that is what we were expecting, okay? Next, what about the surface area? So if we do the surface area is two-dimensional, which means that the surface areas will have been affected by a factor of k squared, meaning to go from here, from this surface area to that surface area, that would have been k squared, affected by k squared, the scale factor squared, right? Multiplying it would get you this. And so we go k squared, surface area of the new, divided by surface area of the original. And I'm just going to write those down. We've got both surface areas there. So 589687 centimeters squared. And we have 2889, this one right here, 0.4678 centimeters squared. So I basically calculated the surface areas of both to 4 decimals, right, to make it a little bit more accurate. If you cancel that out, and now if you divide these, you get this. Let's, I'm going to show that on the calculator here. Right, 589687 divided by 2889, 4678, you get this. And you're probably thinking, right, that's not the scale factor. Scale factor is 0.14. This is not the scale factor. Let's take it further, because remember, this is not k, this is k squared. You just found out what k squared is. So if you wanted to find k, you need to square root this side, and you need to square root the other side too, our answer here in this case. We could have square rooted this, but I'm just going to use that because I have that on my calculator. And what do we expect to get when we square root? I hope you know that it should be that, right? So we're going to go copy paste that, and we get 0.1429, right? That's what we expected. But this is what the one-dimensional measurements have been affected by, this here. This is what the surface areas have been affected by. Surface area has been affected by 0.0204, right? Which is really k squared, which is k squared, right? If you were to square this, if you were to square the scale factor, you would get that. Let me give you another illustration. If you take this number back here, right, we're going to use that in a bit. I'm just going to show you that if you want to take 2889.4678 and you multiply that by not k, but k squared, because we're talking surface areas, if you multiply this by k squared, you should get this. And there you have it. Right? So surface areas have been affected by k squared. To get from here to here, you went times k squared. And to go from here to here, you guessed it, it will be k cubed. All right? So I'm just trying to let you see that everything is connected here, but this is key here to start off with that, and then surface areas are affected by k squared. Okay. By what factor has the volume been affected? Volume is 3D, which is k cubed. Right, so k cubed is volume of new, volume of original, and there you have 20.9440 centimeters cubed, and here you have 7183.7752 centimeters cubed. Cancel that out, and let's see what we get. We get 0.0029, and that keeps going. Doesn't really look like the scale factor, but hold it. Right, we will cube root this side, and we will cube root the other side. And then we're going to get k. So math 4, option 4, so I just press 4 to call cube root. It's a little bit brighter. Call that, paste it in, and there you go. You get 0.1429 rounded, right? So that is still our scale factor, never changed. But this, right, volume has been affected by 0.0029, which is k cubed. So again, if you were to take 7183.7752 and you multiply it by k cubed, so how about we try that? We just take k and cube it. So volume times k cubed, we get this number right here. Sorry, this times k cubed, that number right there. So this is k cubed, this is k squared, and it's just different because any decimals that is less than 1, if you square it or cube it or raise it to any power, it will be even smaller, right? It's almost like saying half of half of half, right? If half is 0.5, right? You keep getting a smaller number. What's the actual scale factor? I'm going to go back to the very top and just state what we already know. Okay, that is the actual scale factor. The new shape is 85.71%, sorry, I don't need the percent sign, smaller. And that is just by going 100 minus 14.29%, right? To get that. You don't need that dot there. So there we have it. Next page. You can always slow me down, go back, do whatever you need to. So here we're going to simplify it a little bit. If two similar objects are related by a scale factor of 6/7, that is saying that K is 6/7, guys. That's what that is saying. Then, right, the areas or the surface areas will be related by a factor of K squared or 6/7 squared. Now you can do whatever you want. You can divide this and then square it. But I'm going to square the top, which is 36, and I'm going to square the bottom, which is 7 times 7, 49. That ends up being 0.7347 or 73.47%. So they've been affected by K squared, by this. This is what I want. You can say it this way or that way. It's up to you. The volumes will have been affected by a factor of not just K, but K cubed, or 6/7 cubed. 6 to the power of 3 is 216. 7 to the power of 3 is 343. That amounts to 0.6297 or 62.97%. Okay, so that is just a fact. When I say areas or something two-dimensional, it's not K, it's K squared. Volumes are related by a factor of K cubed. All right, let's move on. I'm reminded of the fact that I didn't finish this part right here. Okay, on page 37, so let's go and do that. So, determine the amount of ice cream the smaller cone can hold. So, the amount of ice cream can hold. This is hint for volume. Volume is 3D, which means that you have to go and consider K cubed formula. So I'm going to start with that. K cubed is volume of the new over volume of original. I might run out of time because of my next class, so then it'll just be what it is, okay? I might end it here. So K cubed is volume over volume. All right. Do we know this scale factor? Yes, we do. Yes, we do. We already actually came up with it up here. And I'm going to use this version. It's either the fraction or the decimal that I use. So let's go with 0.708 cubed. Don't forget that. And we know that the volume of the original is 2454 cubic inches. Therefore, let's call the volume of the new one unknown, so we're going to call that y. Okay. We're going to call that y, and here we go. Cubit this one. Clear my screen. 0.708 to the power of 3. You don't have to write down the entire thing, but just make sure you use all of it, right? All of the decimals. And now we can insert the 1, right? So it's cross multiply and divide. So to get y, we're going to go 2454 times 0.354 ... divided by 1, which is really not necessary. So I'm just going to go 24.54 times that, and we get 8.71 cubic inches because those were the only units present in this proportion. Okay, and it makes sense. It's a smaller cone. It should be less. The volume should be less. So check your answers, because sometimes if you don't place values in the right place, or if you didn't cube it, then there might be a problem there. Okay, so there is that. Let's see if we can go. I think I have a bit more time to do the cans here. These are exactly the same, and you know what? I think I'm just gonna show you the answer and walk you through it, or should I? I think I have 10 minutes, so I think we can make this work if you want to watch it at any rate. And so Coca-Cola has made a new larger pop can. So right away I'm going to say, hey, this means that this is the new one and this is the original. Okay. The original can is able to hold 355 milliliters and requires this much, right? 322.57 squared centimeters of aluminum, right? Because you're making the outer part of the can, so it's a surface area, while the larger can hold 500 mLs. We don't know the surface area. Notice that? Okay. It says here, determine the scale factor. Determine the scale factor used to create the new can. And here, it's a little trickier because so far, or at least we started off always just saying, hey, let's take both heights or radii, right? And then come up with a scale factor that way. In this case, what are the two things you know? We know both volumes. See that? So it's almost like you know how we had corresponding sides? We would use that. In this case, right, we have both volumes, so they correspond. So that is a three-dimensional measure, which should tell you we got to use k cubed here. Okay, so this would be step one. Right? Identify, hey, I've got both volumes. It's three-dimensional. It's k cubed. I'm going to start with that. K cubed is volume of new over volume of original. So I don't know k. It's got to stay like that. Volume of the new one is 500 mLs. Volume of the original is 355 mLs. Perfect, cancels out. Next step, you guessed it, cube root. I'm going to do it right here. Cube root. And it was determined, it all goes back to volume, knowing that I have to use k cubed, right? And that determines whether to use square root or cube root. So this cancels out. And so k is cube root of that. And we can probably do that in one shot, but I'm a little weary of that because just in case we make a mistake, this way I know what you're doing step by step. So now I'm going to go math, option 4, and cube root that, and that's 1.12, right? And if you want to multiply that by 100, that'd be 112.09%. So what do we know here? This is just a reminder. New can is 12.09% larger. Okay, we know that just by looking at that. That's just an aside. How do we know it's larger? K is bigger than 1. Diagram, different volumes, right? But K scale factor is probably your best way to justify. Calculate the amount of aluminum required to produce the larger can. Okay, amount of aluminum, that's surface area. That is two-dimensional, which means the surface areas are related by a factor of k squared. Okay. Centimeter squares gives that away as well. So I'm going to start with this formula and see what I know. Surface area of new, surface area of original. Okay, you have it like that. I would say pause, like I actually should have said that before. Maybe always try it yourselves, then you watch this, okay, at a higher speed. So you just, do we know K? In this case, we already do know what it is. I'm going to use that decimal. And I can use the rounded answer because once you do part B, it's kind of like you can get the rounded answer from up top. 1.12 squared. What do we know? We don't know the surface area of the new, so that's x, but we do know the surface area of the original. We needed 322.57 centimeters squared. Okay, and there it's just proportional reasoning, right? You should see the one underneath. So we're going to go 1.12 x squared. So we're going to square that. In this case, it's finite. X over 322.57 squared centimeters. So our answer is going to be in squared centimeters. So x is going to be cross multiply and divide. And that gives you 404.63 centimeters squared, which makes sense. It should be larger, right? It should be more aluminum required to make that new can. All right. How are we doing so far? I hope you're doing all right. One more. I think I'm going to have to close it here. Determine the height of the larger can. The height is one-dimensional, which means you're just going to use K as like that formula, the very first one. So you're going to go height of new over height of original. K is just 1.12. Height of the new one, unknown, so we're going to call that Y. Height of the original, 12.2. I should have made it the other way around, but hey, it is what it is. Put the 1 there if that helps you. So that's 12.2 times 1.12. Hey, it's like adding taxes. And that would be 13.66 centimeters. If you want more, I just have a note for myself here. Textbook. They're like this, textbook. And the answers are at the back. Okay? So if you want more, there it is. Let's keep going. This one I'm just going to show you and go over it. Here it is. Whoa, that's busy, right? So basically, you have a kite using a model. So when it's model, I use diagram, right? So Jasmine is making a kite using a model made with a scale, right? The scale, which allows us to find a scale factor. To build the scale model, you need fabric of 20 centimeters squared. I turned this into K, and there are no units, so that's perfect. Determine the amount of fabric needed to build the actual kite. Answer in centimeter squares and inches squares. That's just to get you to practice your conversion yet. But because it's fabric is two-dimensional, right? It's a surface area. Therefore, it's K squared, right? So I use this formula to get me started. I already know what K is. I insert it as a fraction. I know that the diagram, right, the model is 20 centimeters, and I will find out what it is for the actual kite. So you set it up. I square both numbers individually, cross multiply and divide. So you don't need to put the 1 underneath when it's like this, right? And then you get your answer in centimeters squared. What I did here is, watch this. How did I get this number? I knew that 1 inch has that many centimeters, so I just squared that, and now you get 1 squared inch is this many squared centimeters, so boom, right? Cancel that out, so you get that many squared inches or that many square centimeters. So this is just going back to the beginning on how to convert there. Next, Jasmine made another model using 500 centimeters squared of fabric. So remember, the actual doesn't change, right? But you're making different models. Made another kite using what scale factor would be required to make this model? Okay. And I will just let you look at that and see for yourself. So made another kite using this much of fabric, right? And so we need to know that we're looking at fabric again, so it's K squared, surface area of diagram, and actual, okay? So we're gonna go with, start with this formula and then just plug in what we know. We don't know the scale factor, so we just go 20 centimeters squared, that's the scale, the diagram, and 500 is the new actual. So that is the scale factor that was used for this particular model. And I think it's a little bit confusing because it goes off of it, like goes back to making another one. So don't worry too much about this one. Let's do this example here. A sphere has a volume of that many cubic meters. If a replica is made that has this many cubic meters, determine the scale factor used, and I tell you it's 8.75. Ignore this part, right? But it's volume, right? So K cubed is volume of new and volume of original. Why am I using new and original? Because a replica, right, you're making a new one. So I'm going to go K cubed is volume of the new one, 77 cubic meters, over 1475 cubic meters. Cancel that out. Next step would be to cube root both sides. And that's how you're going to get your scale factor. Keep on saying that I'm going to stop and then I don't, right? It's just in case you're stuck. So when you divide these two, you get that, and then math 4, copy, paste. So there you have it, 8.75 is your scale factor. Okay, so I hope that helped. See you Monday.